Hello children, let's start with a new topic of laws of motion, and the name of the topic is momentum and Newton's second law. The objectives of today's topic are: what is momentum? Give its units. State and explain Newton's second law of motion. Now let's start with momentum. What is momentum? The quantity of motion possessed by a body is called momentum. It is measured by the product of mass and velocity. Since velocity is a vector quantity, so we can say momentum is also a vector quantity. The formula for finding momentum is P equal to m into v. As the unit of mass is kg and velocity has the unit meter per second, therefore we can say the SI unit of momentum is kg meter per second. Let's study momentum in detail. Children, in this picture you can see a bicycle and a car. We have taken the condition that both the bodies are moving with the same velocity v. Now, as the bicycle has smaller mass as compared to the car, so the momentum of bicycle will be smaller as compared to car. We have used the concept here P equal to m into v. When v is constant, then momentum is directly proportional to mass. Smaller the mass, smaller will be the momentum. Larger the mass, larger will be the momentum. I hope children you have understood this concept of momentum. Let's take another example. Here in the picture we can see a bus which is moving with a very small velocity. But the bus still has a large momentum. Why? The reason is, even though the velocity of bus is very low, but because of the large mass of the bus, the momentum of the bus is quite large. Children, let's start with Newton's second law of motion. In Newton's second law, we will be discussing the concept of momentum. That is why I have already explained to you momentum. According to Newton's second law, the time rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction of force applied. Now let's start the derivation. Consider a body of mass m moving with an initial velocity small u and final velocity small v. As we already know, momentum is given by the product of mass and velocity. Therefore, the initial momentum of the object will be m into u. The final momentum of the object will be m into v. The reason behind is we have already taken the initial and the final velocity as u and v respectively. Now children, the change in momentum is written as final momentum minus initial momentum, that is m into v minus m into u. The rate of change of momentum is given by m into v minus m into u divided by t. Now children, according to Newton's second law, force is directly proportional to rate of change of momentum. That is, F is directly proportional to m into v minus m into u over t. And on taking m as constant, we will get m into v minus u over t. Children, according to the definition of acceleration, the rate of change of velocity is said to be as acceleration. So A equal to V minus U over T. On putting the value of acceleration, we will get F is proportional to m into A, and on removing the proportionality sign, we will get F equal to K into m into A. Here K is a constant of proportionality and its value is 1. From here we can define force and its SI unit Newton. So children, what is 1 Newton? 1 Newton is the force applied on an object of mass 1 kg to produce an acceleration of 1 meter per second square. The CGS unit of force is dyne. Now children, what is 1 dyne? 1 dyne is the force applied on a body of mass 1 gram to produce an acceleration of 1 centimeter per second square. 1 Newton is equal to 10 to the power 5 dyne. Now let's understand the concept of force. Here in this picture we have two trolleys. One is empty and the other one is filled. Which would be easier to push? Now students, as you already know, F equal to m into A. If the mass of the body is more, the acceleration acting on the body will be less. Similarly, if the mass of the body is less, the acceleration acting on the body will be more. Children, kindly think over it. Out of these two trolleys, which would be easier to push? Children, I hope you have enjoyed viewing the video. Thank you, students.